Now let's talk about different methods for the partition allocation. So there is the fixed partition and there is a variable size partitioning. How we can allocate the process into the partition, for that we have different algorithms. The first algorithm is called first fit algorithm. What happened in this? It scan all the possible holes. Holes means, let's say we have a chunk of memory. So you assume that there is OS resides. So we have chunk of memory available with different size. Let's say 4 MB, 5 MB, 3 MB, 2 MB, 6 MB, in that way. Now, if we have a process one, it required, let's say, 5 MB of memory. Okay. So what happened into the first fit algorithm? It scan all the possible hole, and whenever it finds the first big enough hole, hole means the free space to store the process, it stop scanning and load the process into the hole. So it will start from the beginning, very beginning. So it find out 4 MB is there. Can it accommodate? No. 5 MB is there. Can it accommodate? Yes. So P1 will be accommodated here, right? So this is how this uh, first fit algorithm could work. Okay. Now let's say we have another example. We have P1 is of, let's say, uh, 5 MB again. Then we have the next fit algorithm. So you assume that P1 was accommodated, P2 is, let's say, of uh, 5 MB. So I have accommodated already P1. Now what next fit will do is, it is similar to the first fit algorithm, except the fact that the next fit scan the hole from the node where it is previously allocated the hole. So let's say what is the previously allocated hole is here in the 5 MB. Now it will start the scanning from here only. From here only it will start the scanning. Next fit does not scan the whole, it starts scanning from the next node. The idea behind the next fit is the fact that it has scanned once, therefore the probability of finding the hole in large in the remaining part of the list is very high. So that's why it is going for the next one. So it will not scan this one, and this will be left, this one will be left, and the rest one means after this accommodation, it will scan it. This is a non-popular algorithm. We generally do not use these algorithm into the system. Now the next one is the best fit algorithm. What it will do is, it will try to find out the smallest hole possible that can accommodate the size required to the system. Now let's assume that this is the scenario, and my accommodation that is required is, let's say, 3 MB. Okay, and I'm using best fit algorithm. This is the scenario. My next is P2. I need to accommodate P2 with 3 MB. So what best fit will see is, it will scan all the possible partition. Now one partition is 4 MB. Can it accommodate here? Because it is more than that, it should accommodate, but best fit says that no, we have to find out the best possible fit, means the minimum size which cannot accommodate this 3. So 4 for that, it will not accommodate here because it has to scan all, means from all possibility it will find out. 4 is there, no. 6 is there, no. 2 is there, no. 3 is there, no. After finding all the thing, what it will do is, it will see 3, 2, 6, and 4. Which one is the best? So it will find out 3. So P2 will be accommodated. This will happen into the best fit, right? Now let's go to the worst fit. The worst fit algorithm scan all the hole every time and try to fit out the biggest hole which can fulfill the requirement of the process. Let's assume that right now there is a P3, it required only 3 MB. How much? 3 MB. So it will scan 4. Can it accommodate into the 4? No, it will not do that. Why? Because it has to find out the largest chunk of memory. Which is the largest chunk of memory here? 4 is the not largest. 6 is largest. So it will scan all. It will scan 4, it will scan 6, it will scan 2 and find out the largest one. So 6 is the largest one. It can accommodate the P3 here with 3 MB. Even though 3 MB is left, it doesn't matter. This is worst fit algorithm. So I think you understood the first fit, next fit, best fit, and worst fit. In the example, will means in the implementation, we'll see only first fit, best fit, and worst fit.